Hello, and welcome to our Bitesize Asbestos Awareness Training course, brought to you by Alcumus PSM. In this session, I hope to give you an insight into the use of and the problems associated with exposure to asbestos. Once described as the magic mineral because of its numerous beneficial properties in industrial and domestic use, and now labelled the evil dust because of the recognised long-term ill health effects from inhalation of asbestos fibres. During this bite-sized session, I will be describing the beneficial properties of and the different types of asbestos, and also looking at where asbestos materials are utilised in buildings. In addition, I will be considering the ill health effects of exposure to asbestos. Asbestos is a naturally occurring mineral and has been mined and used for many years. Evidence has been found of its use in ancient Egypt and Rome, and even before that in ceramic pottery dating from 2500 BC. The three most common found forms are crucidolite, or blue asbestos, amosite, or brown asbestos, and chrysotile, or white asbestos. These are the most widely used types of asbestos in building materials, and each have differing properties and morphology, so the size and shape of the fibres are different on a microscopic scale. Blue and brown asbestos are both amphiboles, with characteristic brittle needle-like fibres, whereas white asbestos is serpentine, with a soft, curly S shape. These differences in morphology have a bearing on how easily they can be inhaled and how far they can penetrate into the respiratory system. There are many beneficial properties of asbestos, leading to its widespread use in industry and also in construction materials. As we can see on the slide, asbestos has a wide range of desirable qualities that saw its use increase as more and more products came to rely on this versatile magic mineral. From artificial snow used on film sets such as The Wizard of Oz and also used to decorate homes at Christmas time, to cigarette filter tips, through to surgical thread used to close wounds because of its flexibility and high strength. Let's look at just a few examples. Asbestos fibres have a higher tensile strength than steel. When mixed with other materials, its strength and its flexibilities allow the manufacture of many useful construction products, such as the asbestos cement roof panels as shown. Renowned for its flame and heat resistant properties, it was historically used in woven tablecloths by the Romans and others to prevent fires caused by candles. It was also a remarkable and easy way to clean dirty tablecloths and even clothes woven from asbestos fibres by just throwing them into the fire, a trick often used by the Emperor Charlemagne to amuse his guests after a dinner party. A later, less entertaining use was for fire blankets, as depicted on the slide. Here we see it used as lagging around a hot water or steam pipe, shielding other components from high temperatures, and also minimising heat losses from the pipework. Its use as a thermal insulator in a wide variety of forms led to insulating products being the primary source of exposure to workers. Asbestos will not carry an electric current, and in this picture we see it used as an insert within the fuse carrier, ideal for this purpose due to its electrical insulating properties and also its resistance to heat, preventing damage due to the high temperatures dissipated when a fuse ruptures. The chemical resistant properties of asbestos made it an ideal material for using gaskets, for valves and pipe flange joints, ensuring a good seal that was resistant to the chemicals within the pipework. So we see how useful this magic mineral is, and that it is used for many purposes. But for all its attractive, versatile properties, asbestos fibres, when inhaled, can cause irreversible damage to lung tissue, leading to life-limiting conditions. In ancient Rome, the historian and philosopher Pliny the Elder noted the disease of slaves amongst those who were enslaved to mine asbestos. So there had been knowledge of the ill health effects of asbestos for a considerable amount of time, before all forms of asbestos were eventually banned from use in the UK in 1999. No building constructed from the 1st of January 2000 should contain any form of asbestos. However, that leaves a large number of buildings constructed before 2000 where there is likely to be asbestos-containing materials throughout the building, as illustrated. Asbestos in good condition and undisturbed poses no risk to health. If it is disturbed, it can break down into sharp fibres and be breathed in. The fibres lodge in the lungs, and because of their chemical resistant properties, they do not dissolve. The size and shape of the fibres determine how deep into the lungs they can penetrate and the level of damage caused. Blue and brown asbestos are considered to be the most dangerous due to their needle-like fibres that can penetrate the lung tissue, whereas chrysotile is considered to be the least dangerous due to its serpentine, silky S-shape, which is less likely to remain lodged in the lung tissue. Inhaling asbestos fibres can lead to 4 main diseases: pleural plaques, asbestosis, lung cancer, and mesothelioma. Localized pleural plaques, or diffused pleural thickening, is a scarring of the lung tissue that rarely leads to severe symptoms, whereas asbestosis is a scarring of the lung tissue in the area of the lungs that can lead to progressive difficulties in breathing and potentially lead to death. Around 40,000 deaths a year are due to lung cancer. The vast majority are associated with smoking, although approximately 2 to 3% are associated with exposure to asbestos. There is also a synergistic effect of smoking and exposure to asbestos combined, which increases the chance of developing lung cancer in a smoker from 13% who haven't been exposed to asbestos to 50% for smokers who have been exposed. Mesothelioma is a cancer of the pleura of the lung, the lining of the lung, which is only associated with exposure to asbestos, and currently accounts for approximately 2,500 deaths per year. These ill health conditions are not apparent immediately after exposure, and it can take many years before symptoms are presented. One of the main benefits of asbestos was that it was widely available and relatively cheap, leading to its wholesale use in many products, and was difficult to replace even when evidence of ill health was attributed to exposure. Asbestos had turned from being the magic mineral that could be put to a multitude of beneficial uses to the evil dust that caused injury to bronchial tubes and lung tissue because of the glass-like, jagged nature of the fibres. Despite the early warnings, it took over 100 years for asbestos to be prohibited for use in any form in the UK. Asbestos-containing material only becomes a danger when the asbestos fibres become airborne. Therefore, the risk associated with the material reduces with the level of encapsulation and how closely bound the asbestos is within the host product, as is shown on the slide. Loose and sprayed asbestos, insulation on pipework, and insulating board products have the highest potential to release fibres, whilst those encapsulated in resin or bitumen have the lowest potential. It therefore follows that if work is to be carried out on products with the highest risk levels, then the strictest levels of control strategies to prevent exposure to fibres should be adopted. This high-risk type of work should only be undertaken by competent licensed contractors. As it is highly likely that a building constructed before the year 2000 may have asbestos-containing products in some of the construction materials, it is important to be aware of where the asbestos-containing materials are, so that the appropriate precautions can be taken when working on those materials. It is a duty under the control of asbestos regulations that the person in control of the premises takes reasonable steps to determine if any asbestos-containing material is present, and to put arrangements in place to manage that asbestos, which may be to inspect the materials on a regular basis to check if the material has been damaged to an extent where fibres may be released. For those that are required to carry out work on asbestos-containing materials, then a risk assessment should be undertaken to determine the level of risk and the appropriate control measures. Work that has a high level of risk has to be undertaken by licensed contractors. The different levels of risks are shown on the slide with the corresponding category of work. All work with asbestos has some element of risk associated with it, and the appropriate controls should be implemented. The Health and Safety Executives has produced a set of guidance notes to provide advice on the types of controls that should be implemented, which can be found in the Asbestos Essentials section of their website and are downloadable free of charge. As well as the physical and procedural control measures that must be implemented, anyone involved in working on asbestos-containing materials should receive the right level of training to enable them to work safely and carry out their task. So to conclude, all types of asbestos are considered to be dangerous and be the cause of life-limiting ill health conditions. They can be found in almost any material used in construction in premises built before the year 2000. Any work on asbestos-containing materials must be risk assessed, with appropriate control measures implemented, which may include using licensed contractors. Finally, anybody expected to carry out work on asbestos-containing materials must have been given adequate training. We hope you've enjoyed this bite-sized course, and if you need any help in implementing your health and safety or human resource management arrangements, then please contact us at Alcumus PSM on 014 84 439 930 or visit our website at www.alcumusgroup.com. Thank you for listening and goodbye.